My name is Alex. I'm Microsoft AI MVP and also MCT. Microsoft AI MVP, I'm from 2020, so nearly 3 years now, and MCT since 2012. So it's nearly 10 years now as Microsoft certified trainer. I do provide trainings to our customers to get them started to all of these technologies that you can see here, also on Azure, also on development with Azure DevOps, for example, on security with Microsoft Azure or Microsoft 365, or also enterprise administrator for Microsoft 365 for all of these services, so Exchange, Teams, and so on. So I'm also a PhD candidate at KIT in Germany. My thesis is on language understanding, language interpreting, NLP, dialogue systems, and so on. So all natural language user interfaces, how to build them, and so on. I'm CEO and Solution Architect on AST Germany. That's a company that's a spin-off from KIT also. We offer consulting services for Microsoft products and technologies, and we are a 10-time Microsoft Gold partner. You can see my information, my contact number here. If you want to reach out, it's a pleasure to meet you there on LinkedIn, on Twitter, and so on. So where am I from? I'm from Germany, and we also have here Microsoft AI User Group Germany. We have only 360 members. So if you look at your meetup at Pune, India, that's really big. So we started this perhaps 1 year ago, 1.5 years ago. So we are still growing there. But if you like to join, we do also session in German, but also in English from global meetups that are digital as this one. And I'm thankful to speak to you here. So if you would like to join, please do this. So what is AI and machine learning? If you look, I love this picture, because if you look at this picture, first of all, I see statistics. What are statistics? They are based on calculation, analysis, interpretation of data. So this is mathematics. So you get the frame, and after this is machine learning. Great. Machine learning gives computers the ability to learn without being explicitly programmed for that. So if you look at this, machine learning is based on prediction of output based on historical data input. So I give you an input data, and then want you train your model, you get your algorithm running, and so on. I will talk about this and show you how exactly this work on the Azure platform. And then I get you another data, the new one, and I hope you predict what kind of data this is with your algorithms and your model. So machine learning is just a calculation of probability. What kind of data should it be, for example? And if you look at artificial intelligence systems are able to perform tasks normally requiring human intelligence. So if I talk about artificial intelligence, then I give you something that you have never seen before, and with your human brain, you get after your insights, you get after the historical data you learned over the years. You provide me the information I need for the new data without anything, because your brain is already trained for this. That is exactly what we expect from the machines. But first of all, that's really funny. How to break the AI or machine learning systems. First of all, we concentrate the whole time on building models, and also building models. You will see this later on the Azure portal. We have been focused on this a lot. And the problem is that we must turn to data. So our data are really bad. Our data quality is not right. We have a lot of false positive after running the whole algorithm and so on. So we need it provides on the data quality. If the data is great, that provides you a great also precision or the great probability, the great calculations from to the output you need. If you look like this and your model would give you the characteristics that this is a dog, then you're definitely wrong on that. And how to confuse AI? I think that is a really great example for the data you trained your machine learning algorithms, because they all look similar. Are they? Yes. But the AI system just only look for eyes and nose, eyes and nose, eyes and nose, eyes and nose. And then after the while, you don't get it for the brain from your side. You need more context from your human brain. You look also not only for eyes and your nose, but you look also, is it right in the form? You need more context on this. And AI or also ML systems, you can break them really fast if you don't if you learn one kind of data and then you try to ask, okay, what is this picture about? Is it a dog or is it a muffin? So from a human perspective, you will see, okay, oh, that this form that looked like that's a face. That's also looked like a face. That's this no, this also no, because you look also from this curve. You look from for your form from the picture. So you get more context and try to get your 3D picture on that. So that's how, if you give your model only one kind of data, so you are here, your data is not really great, your model is really good, but you still get some kind of these wrong answers from your Azure Machine Learning prototypes. If you look to the Microsoft AI platform, they provide us a lot of services, a lot of tools, a lot of infrastructure um, to get this run. This is cloud powered AI, so you don't need to set it up locally, and that's why AI gets this push from the industry right now, because we learned that cloud is really great for providing everything big, everything, also a lot of computing stuff for only 1 or 2 hours. You pay, for example, $9, and then you get your data calculated, you get your output, and so on. If you have to buy it right now to your on-premise data center or for your on-premise client, for your premise computer, and it doesn't work really well because you have to pay a lot of money. Then you have a really great big hardware computer system there, and then you provide, you also build your services. We have it earlier on the conversational AI, your bot framework. You have to put a lot of time, also effort to program this chatbot. That is also my PhD topic. We have done this on our own. If you are running at the university, you want to do PhD, you're not allowed to use cloud services or external services at the end. You should do your own experiments, your own software engineering, and so on. So you can run it, of course, in the cloud, and so save a lot of money, a lot of time, and so on, and start on the fly. So you can see it. I have 2 demos for you right after. We can go on and just use these services, just use these tools, just use infrastructure as service that Microsoft provides to us. And for example, today we do an introduction to Azure Machine Learning. That is a custom AI service from us, from end user. It's here from Microsoft perspective. So we are starting on this. Of course, we can look for pre-built AI for cognitive services, or do conversational AI, or just coding management tools, use Azure ML Studio, and so on. I will go there in a few minutes. So just imagine we have one of these scenarios, and you have built it on your own in your local data center. That is really, really hard working on this, because I just want to have some user and movie interaction data here in my first step. You can also look it up. On Microsoft Learn, I provide you, if you like, also this kind of information here. You can look it up, and also set this scenario up in your environment or environment from Microsoft as a lab, if you like. So I would say in the first demo, I would talk a lot about this one, then the next one, just to show you how does it work, and also explain on you how does it fit to all fit together. So first of all, okay, we need our Azure Blob Storage in our Azure environment. Of course, Blob Storage is for unstructured data. So I would just save here pictures, videos, movie data, whatever I want. This is just your compared to your OneDrive folder. This is just you just get there the folder structure and say, okay, this folder is for logs, so this video is for videos, this folder is for pictures, and move so on. In the third step, I can use this data for my data science virtual machine. I can also use other data from GitHub, from somewhere else, online data, or also from blob storage, or from whatever I want. I can compute here something, and also store Azure Azure Cosmos DB. This is a JSON format data that I would store here. It is a geo-replicated storage. Performant is a really performant for my tasks later. So I can use this for JSON storage, and also give my models to, or build my models after this to Azure Machine Learning service, and then provide to my user client from, for example, it could be a container, it could be a web app running in a container, or something like this. It can be everything. So you get some endpoints here. I will talk about it a little bit later. And then your end user just ask your endpoint from your model, okay, what is this picture or this movie about? And then your model will calculate the precision on this and tell you, okay, what kind of data do I see now? Okay, we are already 50 minutes in this session, so I think it's time for our first demo. In this demo, I pre-recorded this demo because I have only 45 minutes, and also with the Q&A, so I just cut it down to all of the stuff where we have to wait a lot. So first of all, we just built our data science virtual machine. So I'm logged in to Azure portal, as you see with my account, and then I can go on and just choose data science virtual machine. In this case, it is a Windows Server 2019 machine. After this, I can choose the right region, and also, if you see here, choose if I want one machine that have 4 CPUs and 14 GB memory, then I have to pay 320 euro a month. In this case, this machine would run the whole time, so the whole month. That is also not the best practice for Azure, because if I need this machine to run only 2 minutes, then I should pay also for only 2 minutes to run this on Azure. So in this point, We can choose whatever machine we want, but just imagine here, just save in your mind. We can choose a machine with 4 or 8 CPUs, also with GPUs later, but they are still very expensive if they run the whole day. If you don't need this kind of machine and you want to set up this, why do I think it's really great point to start, because this data science virtual machine, this machine, this has a lot of tools that you need to set up to run your machine learning services in this virtual machine. So Microsoft prepared this machine for us, and we just create this machine. We can also do from this kind of perspective, we do only premium SSDs for our operation systems. We do not need perhaps one extra disk. We let it is. Then we go there. We get public virtual network and also a public IP, so we can connect management, and also here extensions. We can go there and just review and create this machine. So this kind of machine I have already created, so we can go on. So just imagine you just put there and say, okay, I want to create this machine. Then it will last perhaps 10 minutes, 15 minutes. Will it go on? Then it's created. You go there, connect to this, put in your login name and your password, and you're already done, and you can go on and use your all services and so on in this data science virtual machine. So we are going to log in now, and then you see, okay, if you see there's Microsoft Teams there, okay, I don't need this on this machine, but okay, it's already instanced. You can ignore this. We have virtual machine code. We have some SDKs here installed and so on. So for example, if I'm running the Jupyter notebooks here, that last for 1 or 2 minutes, and then we can see this kind of information on our screen. It starts as localhost, as you can see at this machine locally. So I can also do some training with small data sets, perhaps inside this machine. But if you are going there and put your Azure Machine Learning services, set up this Azure Machine Learning services, you can go there and also use more data or big data to run this on Azure Machine Learning. This page redirects us to Jupyter Notebook. That's only one moment, and then we see the result. I'm sorry, I have stopped the video. That's why. So we are already there. And then you can see, okay, Microsoft Teams, we can ignore this. Azure ML, and then you are already there for starting and running perhaps first tutorials. So I just go there and see what is there, create your first experiment. So the point is there that you can just imagine you can also run this kind of experiments, this kind of information also in your local machine. But I wouldn't expect you to do this, because you have to install all of these required tools and so on. It is easier because it's costs only a few dollars to set it up. To run it is in one virtual machine if you're not familiar to Azure Machine Learning. But I will say, I will say, let's explain me this one, and then we go to Azure Machine Learning, and then you can compare and see the difference on this. First of all, of course, we have to connect with our Azure Machine Learning workspace, create the experiment there. That is of course, we need one Azure Machine Learning workspace, a subscription, and so on. You see this kind of error if you do not have this. Perhaps you can go there, load data, train data, and so on. So you go there and do this also from your virtual machine data service. Okay, that is a cool idea how to start, but what's about the Azure Machine Learning? We can go there and also create in our subscription. Perhaps we go to our subscription and then we created perhaps already there this kind of virtual machine. Now, this virtual machine is available from Azure ML Network. We have also storage there. It's all great and fun and so on. But then I can also create a machine learning workspace. This, if I create, you get to go there to Azure portal, just type there machine learning workspace, and then you created this one. The idea behind this is that you get your machine learning studio there, and you have already set up to get your notebooks there, to get your designer, to upload your data sets, to build your experiments, to go to the pipelines or to build your pipelines, set up your models or just review your models, to set up endpoints. So perhaps a web app can already or use your model on this. So in this kind, you go to Azure Machine Learning Studio, and then we switch to notebooks, and then perhaps you go this aha effect. If I go perhaps to classification, to Azure ML classification, and so on, you see I can also use Visual Studio Code for this, but it's also, you see the automated machine learning notebook is running there. And if I look after this, you will see that it is the same as I was running in the data science virtual machine on Azure. So if I want to get my data inside the virtual machine, for example, and work with this virtual machine, I can set it up, run it there, and if I don't need it, I just delete this virtual machine and then I'm done. That's okay. You can see that you need for running the experiments in Azure Machine Learning Studio, you need some compute services installed or compute services set up. I do not install this on my own. I just set it up. So you can create your compute services here. So that is Azure ML GPU VM that I'm running here, and also Azure ML CPU VM that I'm running here. So this one had 4 cores, 15 giga RAM, and you see I spent only not even $1 per hour. That is and only 27 cents per hour. That's nothing if you compare it to just set up a big VM or even worse, just put this hardware or buy this hardware. And if you imagine this will be run beside me, then it's running in my free time that I am not using it, and I pay a lot of money for that. If I want to go to GPU, you see I get 6 cores of hardware there, one GPU, and that's had 6 gigabyte RAM for that, and it's a little bit more than $1 an hour if I'm running the whole hour. You will see after this, if you run the experiments, you will need only perhaps few minutes to run. So if you do not need the whole hour to run your experiment, then this machine, if I hit run, so execute, please execute this notebook, then this machine will start up, running the experiment, and shut down. So after the experiment is ready, nothing changes to your virtual machine. It slows down, it shut down, and then you have not to pay the whole hour. That is really cool on this point. So I can easily recommend to not to set up the big environment for this. Just use perhaps small kind of services from Microsoft, and then you can go on and just hit CPU if you had a small data set. Just hit GPU if you have a large data set and you need these you need more power to get this done. So you need more power to get these notebooks executed and so on. So this notebook is it's a sample from here from AutoML classification, and you can also easily find it on the samples if you're running Azure portal with one. It's for all of us in the public. That's not only for MVPs. So if you are going to your Azure portal, just create Azure Machine Learning workspace, and then you see here under notebooks, you go there, you can see all of the samples. You can start, and then you see here it is already. I hit execute, so you see that is executing after one. After several seconds, when you get here, you have to import some libraries, of course. You can go there and print something. Also say, okay, your notebook is created in this kind of information. You go further and say, okay, I configure my workspace or I connect to my workspace. And then you have your subscription ID, your workspace name, your resource group. You can see it all here. So that is already, I'm sorry if this was perhaps a little bit too, it was scrolled down too fast. I'm sorry for that. So then you have the subscription ID and so on. And then you can see, okay, is it data correct? So am I using the right point, the right subscription and so on? Okay, then I get there and create compute. Perhaps if you don't create this earlier, you can create compute clusters with nodes. You see maximal nodes is 6. You start with your name is CPU cluster 4. You start with one node perhaps and go there. And if you see the data or the calculation is really big, then it go and scale out automatically for you. And this kind of configuration is done by Microsoft in the backend behind all of these services. That you can also see what kind of VM do you want to start there. The standard D2 V2. That is one that we have seen earlier. So perhaps we are great on this. Go on. We created a workspace, we connected to a workspace, we created the compute, and after this we execute and load our data. So the next step is you have to get data from one example, from your blob storage, from whatever, GitHub and so on. So we executed this, we can look it up and see, okay, our data is already loaded to our systems. That's cool. And then we can go on and see, okay, it's already executed there. We created some paths, we trained validated data, test data also. And then this kind of experiment after the whole, you can see it's all running and so on. It's all executed. And if you are trained these data, that's not an example on how to train a big data. That's example how to start if you want to start with Azure Machine Learning. So we can see also our experiment. It was happened to my last subscription. In my actual subscription, I have to move it there because of subscription has changed and so on. You can see this was on our CPU, our GPU resources that we already created earlier. So this is one computer instances where we are going to run a notebook. And if you are going to hit, I want to have computer clusters, then our cluster is creating here. You can see CPU cluster 4 resizing from 0 to 1 because our experiment is running. And active runs, you can see here, we have 1 and okay, we can also have up to 6 nodes, but in this time, this is ready to run, that executing, and we are going to see and to look up what kind of resources are there. In this point, I think it's okay for this time to see, okay, I can create instances, I can create clusters and so on. So clusters are just 1, 2, 3 instances is a cluster from the same type. And you see our run is completed and it's running. It was running on CPU cluster 4. We can look up the data and it's still running in this point. I'm sorry for that. I thought it was already finished. You can see there are some experiments that run only 9 minutes. There are some experiments that are running 24 minutes or perhaps half an hour nearly. So that depends on data. It depends on your Jupyter notebook. What kind of information do you want to be trained? What kind of programming are you doing in this Jupyter notebook? So after this is on 2 minutes, nearly running, and perhaps you are going to hit another one that already finished, and then you can see, okay, what kind of model do I get there? And then you can just look it up. What have you learned on this? What kind of model is provided by the systems? What can you use? What is your output? What are your logs on this? For example, Azure ML logs, explanation logs, output, and so on. It uses also in the backend Azure Blob Storage. So I will show this to you in a second demo. So this kind of information, that is all also from Azure Machine Learning. So you set up your notebooks, you are running on your data sets. Perhaps when you here can upload your data sets, you see your experiments that are running or already completed. As this one is already completed, so I can look to the model, to the output, to the metrics, to the details, and so on. If I am running and I would say, okay, we nearly need 16 minutes or more on this demo, I just want to show you the demo number 2. So let's try this out to see what is there in the backend, what happened in the backend with our data. Are there what it is stored and so on. So this is our Azure ML workspace storage. So we have created this storage as we creating the workspace. We can also give then the name for the storage, and then you can see that is the blob storage there, containers. So it's still blobs, but Microsoft has renamed these to containers. Earlier, you can also find here blobs, file shares, tables, or queues. So file shares are simple file shares. It's also known from on-premise and so on. Tables, unstructured. I'm sorry, that are not unstructured, but it's like the Excel tables. You can also go there and save here the information and also some queues from your apps traffic. We are going to containers because our data is stored there. And then you can see the metrics, the logs, the Azure ML snapshots, and so on. That is the same data that we have seen on Azure ML Studio. So we see here our we can see here our experiments and so on. The data behind our logs to prepare to troubleshooting for some reason. If something didn't work correctly, I think you can just go there. And for this reason, you need insights from your applications, from your Azure Machine Learning workspace, and then you can find this in the logs. So on this point, we have also, if you go to Azure Portal, you can see a lot of information that is stored there. You can easily create one new container. Just say a container can be reached on the private level. That's okay. We go there, create also one container for images, and also say what is a public access, is it private, or is it to container, or is it on the blob? And then we can easily upload information inside of this image and also provide the data and say, okay, I have some information there. I have to give some data perhaps to the storage. So if you look at the examples at the beginning, we have a user and movie interaction data, and then we go there and upload this perhaps to Azure Blob Storage. From this Azure Blob Storage, we provide access to a data science virtual machine. After this, in the next step was Azure Machine Learning services and so on. So it's easy to upload this through Storage Explorer, of course, or yeah, if you have a big data, then you have to do an import job in a portal and send the information encrypted to Microsoft and then finish the import job. And then you can also see your information here in this information. Yes, but you do only do this import job for real big data if you are in a terabyte area. So if you have on nearly small data, megabyte or also gigabyte data, I don't think you will use this import job, but it's another topic on this. So our experiment 95 is still running. Okay, that's not a problem. I think that will be completed after a while. Then they can also look it up and also explain the information. You can see also that Microsoft uses here voting ensemble to run and to go there and to get this model created and so on, because they uses a lot of different algorithms combined them to an ensemble, and then you get better experience and better results for this. So that's why there's a voting ensemble, and also because why it has the most weighted, and okay, they're all 100%. That's okay for us, but you see that the voting ensemble is the best in this case. And of course, if you are running on multiple algorithms to get your model completed, then of course that will be better and so on. So you can also do an explanation, or perhaps also explain your data set to the customers or to yourself also. You can go there and just imagine, okay, what kind of data do we have in our experiment? What is the inside? What have we uploaded there? See the whole metrics. Also, you can choose whatever you want to show up. That's really cool because it's already integrated and it's already communicating with our systems provided by our data with your Jupyter notebooks and so on. So I just want to make sure that this kind of experiment is completed somehow. We can, we can do another one. So you can see if you want to just set up one new experiment. That is not not really difficult. So I will just tell you how to use it. So you can go there and select one kind of data set that is perhaps already prepared for you. So in this kind, I can get there and say experiment name. Do I set up a new one, or do I want to select existing one? So I want to run new experiment and also say, okay, this should be running on this bike rental data set. So this provided in this case. And then I'm running this on my GPU cluster and hit next. what can I do there? Classification, regression, time series forecasting, and so on. So perhaps if you're not familiar what kind of experiments I want to run, there's a machine learning cheat sheet also available from Microsoft that explains you all kind of classifications that can be done, of all kind of algorithms that are available, and so on, just to find an overview from this side. And if you are going to there, just okay, I want to explain best model, of course. Then what kind of algorithms do I want to use? So random forest or something like this. What is exit criteria? Okay, perhaps I want the training job should be running only 3 hours, and that's enough for me. Validation should be automatic, and we hit finish, and we are set up to run. So I have already done this because it took nearly okay, in this time 10 minutes on this in this case, but it was also okay in from this point. So what can you do this kind of models if you hit endpoints sometimes? So we have seen datasets, experiments, pipelines that you also can build to provide the information to another systems, models, and if you want this kind of experiment of this kind of model should be available for other, then you can hit endpoints and build your private or your endpoint to the web app or so on that can use your model just for further input and so on, and scoring also. So if we hit designer, that's really cool, I think, because you can see also an example as you here text classification, Wikipedia 500 data set. We get this data set already there. And in this kind of designer, this is a no-code, perhaps low-code solution. So you can go there and just imagine you just proceed the data, you can pre-process the data, you can split the data for training or testing and so on. So you just go there and see what kind of information, what kind of algorithms are already there for you prepared by Microsoft. That's really cool because you see how easy is it to start. We spent only perhaps now 14 minutes, but you have seen so many different possibilities how to start, how to train, how to run your notebooks on compute, just in one in one click is it there, and you spend 10 minutes, and it's done for you automatically. You have nothing to do. That's all there. And if you hit designer, you can provide data. You can pre-process the following steps as you wish. You can pre-process the tags, split the data, and just work on this. And just go there in this demo, and you can see there we can choose from a data. Perhaps is it already there or not? This is just drag and drop from this kind, and then we can compare or perhaps also combine existing data or existing processes from one kind of data. Okay, it's in this position. I have bike rentals and Wikipedia dataset, whatever. Perhaps it would make no sense in this, but you should only get the idea how to run it, how to use it. So of course, you can also see another sample data sets there. You can also choose another model training and so on. So this is just an example, and this also autosave is on. Every time I would say I would just even added something that is already saved and that is already provided to the system. After I submit this, okay, then I can run. You can see now we split the data in different processes and we go there and train, score model, evaluate model. And perhaps if we build the endpoint after a while, I don't know why Wikipedia data set is already there, make no sense, we can delete it easily. And then you can see, you can here run one kind of process. In one point here, you need another one process. Hi, Branka. Nice to meet you again. Thanks for joining. So, and then you see here also the models, or your algorithms that are already available. So you can also do this by yourself in your notebooks, but that should be an introduction to you how to start easily. So I can also import all kind of information, all kind of frameworks from outside, but I can also start in this designer just for trainings, just for information, how to run this all. So this demo is nearly done. So we are going to get there. We have our data set, we have our experiments, we have our models, and then that's it. So that is all what you need to run to get started, to get your information there. If you want to know how to become an AI expert, there's a GitHub repo from one company, from what we know from Germany here, and they provide somehow on guidelines how to become an AI expert. Okay, this is a roadmap from 2 years ago. Perhaps there's a new one, but the AI expert can choose to start, okay, am I a big data engineer, data scientist, and so on? What kind of information do I need? What kind of fundamentals do I need for machine learning, perhaps for deep learning, for big data, and so on? I think my time is already over. I thank you for your attention, and thanks that I could speak here. I also thank the PuneTech community organizers, Nandi, Smita, Kuni. Thank you very much. And if you have any questions, you can reach out to me and also provide the information for me to go to answer your questions. Thank you very much.